Good morning, geometry classes. Welcome to lesson 10.7 guided practice. This will be the last lesson for this chapter as we wrap up right before Easter break. So for lesson 10.7, we're going to write and graph equations of circles. Page 689 shows the key concept of what the standard equation of a circle looks like. And so here we have it. X minus h quantity squared plus y minus k quantity squared equals r squared, where the center of the circle is at hk, so whatever number you see inside of the parentheses with the x, you're going to write down the opposite of that number for the x coordinate of the center. And then whatever number you see in the parentheses next to the y, you're going to write down the opposite of that number for the y coordinate of the center. And then the radius of the circle will be found from r squared. When you take the square root of whatever number you see here, that will be the radius of the circle. All right, so our first step is just getting that equation in general form written on our paper. It's also on your theorem sheets already. First guided practice problem is to write the equation of the circle with a center, so C designates center at the origin, 0, 0, and a radius of 2.5. So here's our general form of our equation. We're going to plug in the numbers for h, k, and r, simplify, and then we'll have our equation written. So our h and our k, in this case, are both 0, since we're at the origin. So x minus 0 squared plus y minus 0 squared is equal to our radius, 2.5 squared. X minus 0 is the same thing as just x, so we have x squared. Y minus 0 is the same thing as y squared, so we have just y squared, equals, and then you can think of this as 25 times 25, which is 625 by memory. And then you can put your decimal point in. So there's going to be 2 decimal places when you multiply 2.5 times 2.5. So therefore 6.25. If that's not something that you already have in your memory, you can of course work it out. All right, so our equation on guided practice 1 is x squared plus y squared equals 6.25. Guided practice 2 will be similar, but this time the center of our circle will not be at the origin. Instead, it will be at the point -2.5. Our radius is 7. So we're going to go ahead and put numbers in for h, k, and r to write our equation. So remember, the h and k come from the center of the circle, so you're going to write down the opposite of the number you see here because it's x minus -2 in this case. So x minus -2 is the same thing as x plus 2. And then y minus 5 will be written in these parentheses. So we're replacing k with 5, and that's equal to our radius of 7 squared. We'll go ahead and leave our x plus 2 squared and our y minus 5 squared as is, and 7 squared will rewrite as 49, and we're done. Example 3 says to write the equation of the circle shown. They show you a circle with a center here at -1, 3 and a point on the circle at -5, 6. Now we're going to need to know the radius to write the equation of the circle. We already know the center, so we have our h and our k right here, but we have to calculate the radius. So the radius can be calculated using the distance formula. And our distance formula here is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's go ahead and put our numbers in for our x2 and our x1. So we decide which point we want to designate as our x2, y2, and I'm going to designate it as -5 for my x2, and my y2 then of course is going to be 6. So I'll be subtracting -5 minus -1, there's my x1, squared plus 6 for y2 minus 3 for y1. That's here, squared. All right, now I'm going to work that out and simplify it. So minus a -1 is the same thing as adding. So -5 plus 4 is -4, which I still square. 6 minus 3 is 3, so I have 3 squared. That gives me r is equal to radical 16 plus 9. That gives me r is equal to radical 25, and the square root of 25 is 5. My radius squared would be 25 then. Okay, so now I'm ready to write my equation, my circle. I've rewritten the center here just so I have it in front of me. There's my h and k, and there's my r squared. So remember, I'm going to write the opposite of the numbers that I see at the center. So x plus 1, that's the opposite of -1, squared, plus y minus 3, that's the opposite of 3 here, is equal to my r squared, which I've already written down is 25. Done. Guided practice 3, it says write the equation of the circle, given its center is at 1, 4, and a point on the circle is 3, 4. Well, again, we're going to need to know the radius, and we're going to need to know the center. We already know the center. It's given to us, 1, 4. And this is really overkill here to use the distance formula. Since this is a horizontal segment, really all I have to do to figure out that radius is to find the difference between the numbers that are different here. And so that would be 3 minus 1, which is 2. But if I put it into the distance formula, it'll work equally well. So here I am plugging into the distance formula. 3 minus 1 squared plus 4 minus 4 squared gives me 2 squared plus 0 squared gives me 4. So the square root of 4 is 2. Again, I can figure that out just by subtracting 3 minus 1 here, since it's a horizontal segment, to verify it's 2, and then r squared is 4. All right, now I'm ready to write my equation. Here's my general form. So my h is going to come from my center, which is 1. So x minus 1 squared plus y minus 4 squared is equal to 4 for my radius squared. Done. I got to practice 4, right? The equation of the circle with the center at 2, 6 and a point on the circle at negative 1, 2. So this is similar to the last problem that we just did. We'll first find the radius by using the distance formula. So I'll go ahead and subtract 2 minus negative 1 squared plus 6 minus 2 squared. So there's the difference in my x's, there's the difference in my y's. Squared and added gives me 3 squared plus 4 squared, gives me 9 plus 16, gives me 25. Square root of 25 is 5, so my r squared is 25. And I already have my center given to me, so x minus my h, which is 2 from my center, squared, plus y minus 6 from the y-coordinate of my center, squared, is equal to my r squared, 25. All right, got to practice 5. Okay, now we're going to go the opposite direction. We're going to graph the circle whose equation is given to us. So we need to pull out the center and the radius so we can, in fact, graph it. So our center will be the opposite of the numbers we see in the parentheses. So the opposite of negative 4 is 4. The opposite of 3 is negative 3. There's my center. So I plot that center point. Now I figure out my radius. The radius squared is 16. So the square root of 16 is 4. So my radius is 4. So now I'm going to go back to my graph here. I've already have my center down at 4, negative 3. What I'm going to do is I'm going to plot points 4 to the right, 4 up, 4 to the left, and 4 down. And then I'll draw a circle through those 4 points. And I will label the ordered pairs that represent each of those points. To figure out those ordered pairs, here I start at the center, 4, negative 3. And so when I go to the right and the left, the y-coordinates will stay the same. My x-coordinates will change, and I simply will add 4 to my x-coordinate, giving me 8, and it will subtract 4. 4 minus 4 is 0. That gives me my x-coordinate over here. And then to figure out my ordered pairs that are above and below my center, I'm going to notice that my x-coordinates will stay the same because they're 4 to the right in each case. And then what I will do is I will add negative 3 plus 4 to my coordinate, my y-coordinate. So negative 3 plus 4 is 1. And then I'll subtract 4 from negative 3. Negative 3 minus 4 is negative 7. And I'm done. All right, here comes our last problem, last graphing problem. Graph the circle whose equation is given. Again, we'll pull out the center, negative 8, negative 5. It's the opposite of the numbers you see in those parentheses. My r squared is 121, so my radius is 11. So notice I've set up my graph. Because these numbers are fairly large, I've decided to go by 2s. The solution in your textbook will actually have the graph set up going by 3s. So I need to label what my marks are here. So I've marked every other one to show that that every mark actually is a unit of 2. All right, so go to the left 8, down 5, and there's my center. I'm going to go to the right 11, up 11, to the left 11, down 11, plot those 4 points, and label them. Remember to get the coordinates of my ordered pairs that are to the left and the right. The y-coordinate will stay the same. I'll take my x-coordinate, negative 8, plus 11 is 3. Negative 8 minus 11 is negative 19. To get my ordered pairs above and below my center, notice that what stays the same is the x-coordinate, because all these points are 8 to the left. Then go to the y-coordinate, which in this case is negative 5, add 11. Negative 5 plus 11 is 6. And then negative 5 minus 11 is negative 16. And all of my points are labeled. My circle is drawn, and I am finished with this guided practice set of problems. All right, so now it's time for you to start working on the lesson that this set of guided practice problems goes with, and we'll see you next time.